In this video, we're going to look at how to name ions that form from metals and nonmetals on the periodic table. It's going to be very helpful to have a periodic table in front of you when you're doing this job. And you can find one linked on the website. You can print that out wherever you are. And another thing that we've already talked about that is going to be very useful to know is how to classify metals and nonmetals. There is a little imaginary staircase here. It goes down something like this. If you're to the left of the staircase, you have metals. If you're right of the staircase, you have nonmetals. So you can tell whether you've got a metal or a nonmetal that way. We've already done that. Now, the metals tend to form positive ions. There's a name for positive ions. Cations. So a cation is a positive ion. And the metals always form those. The metals will lose electrons to become like the nearest noble gas when they are in the S block here, the first two columns, and even this metal will do that. These metals, it's a little more complicated. We'll talk about that in a minute. Let's look at the simple cases first. Look at the first column. Everything in this column forms +1 ions. You can see why. If lithium wants to become like the nearest noble gas, which is helium, it's going to lose 1 electron. In the second column, all of the ions form +2 ions. In the third column, most of the things in this column form +3 ions, if they're metals. Now, boron is a nonmetal. Things in the fourth column, you would think that they would form either +4 or -4 ions. In reality, they usually form covalent or molecular compounds. They don't form ions at all. Many of the ones, the nonmetals at least. The metals on the bottom do, though. There is such a thing as a lead +4 ion and a tin +4 ion. Again, we'll come back to that in a minute. Nonmetals here form -3 ions. Nonmetals here form -2 ions. And the halogens in this column form -1 ions. These things don't tend to form compounds at all. They really don't have any charge. They don't form ions at all. So this is something that we had talked about before when we were talking about periodic trends, and we were trying to tie the electron configurations we had done with a periodic property, ion charge. Now, what do we call metal ions? Let's look at metal ion names first. If you've got a metal that is here, or aluminum, or gallium, all you got to do is take the element name and add to it the word ion. So if I say we have Al +3, that's an aluminum ion. You can see it's in the +3 column right here. I will just call it aluminum ion. If I've got a sodium ion, I can see that that's Na +1. Now, when we're writing ion charges, we don't write ones in the charges. That's just a weird quirk that chemistry has. It doesn't put ones in charges. So I'll say that's called a sodium ion. What would this be called? Well, if you look at where it is, it's in the +2 column, so that charge makes perfect sense. You can look at the element name here, barium. Just call that a barium ion. All right, that's fine when I am pretty sure about what the charge is and that there is only one charge on the metal ion. But what if I have ions, metal ions, that can have more than one charge? And this is the case for all of the transition metals here. For all of the things that I have in this area right here. These are all metals. And all of these metals here can have more than one charge. Now, aluminum and gallium here are metals, but they both have +3 charges on their ions, so they're pretty easy. But if you're inside this little sort of silver-shaped area that I have here, there are multiple charges possible, and you can't tell what the charges are by looking at the periodic table either. If I look at copper here, copper forms 2 ions, a +1 ion and a +2 ion, and I can't tell which I've got from where it is on the periodic table. Now, if somebody gives me this ion and this ion and asks me to name them, I've got to do more than just name the element and put the word ion after it. So I can't just call this a copper ion, and I can't just call this a copper ion, because then I have the same name for 2 different things. So what they do is, for things that are in my silver area here on the periodic table, you take the charge and make it into a Roman numeral and put it after the name. No spaces in there. So this would be a copper 1 ion. This would be a copper 2 ion. You use Roman numerals here. Okay? Now, notice that lead here is in that area. Lead forms 2 ions. We can't just call them lead ions, because then they both have the same name and they're very different. I'm going to call this a lead 2 ion. And I'm going to call this a lead 4 ion. So when you're in that area, you can use these Roman numerals. They're called stock numbers. It isn't wrong to use, some of these do only have one charge, and people don't usually use stock numbers for those. This is an A student thing. It's kind of a fine point. If you put stock numbers on anything that's inside this silver block, everybody will know what you mean, and it's not technically incorrect, so it won't be marked wrong on a test. But in real life, you should know that with silver, it always forms a +1 ion. You would call that, according to what I just said, a silver 1 ion. But in real life, people just call it a silver ion because it's the only silver ion that forms. So silver is kind of an exception. And so is cadmium. You would call that ion there a cadmium 2 ion. I wrote a +2 next to it. But really, cadmium only forms +2 ions, so people will just call it a cadmium ion. And it's the same thing with zinc. It only forms +2 ions. So instead of calling that, you could call it a zinc 2 ion. But usually in real life, people just call it a zinc ion. Now you should be able to name any metal ion. If I have Au+, what would you call that? If I look real close, if I could read that, that says gold So Au plus would be a gold 1 ion. What if I have a chromium plus 3 ion, Cr plus 3? That would be, since it's a transition metal, I have to use a stock number. It would be Cr 3 ion, chromium 3 ion. So if you have this, I would name it chromium 3 ion. Now notice that if you're in the first two columns, or if you are with aluminum or gallium, you're outside of this area here, and you can leave off the stock number. So if I ask you to name this ion, you would just call that a strontium ion. You don't have to strontium ion. You don't have to say strontium with a Roman numeral 2 after it, because that's all that you get with that column. All right, so you ought to be able to name metal ions now. Now, let's look at the nonmetal ions. They're a lot easier to name. You don't have to put the charge at all into a nonmetal name. For nonmetal ions, you're going to take the element stem. That is sort of the root. I could say stem or root here. And then you're going to add an IDE ending onto it. Now, probably you've seen that salt, table salt, is sodium chloride. That's what they're doing there. If you have Cl minus, that is called not chlorine, but chloride. So when I say element stem, it's this piece of the name, and then you put an IDE ending on the end. What do you think this one's called? All right, well, this is F is fluorine. I will cut off that ending. So I keep that part of the name, and then I put an IDE ending on it. This is all one word. There's no space really in there. How about this ion? First of all, if I make an ion out of sulfur here, what will its charge be? It'll be -2. What will its name be? Sulfur, I'll cut the UR off the end and I'll put ide. So it's a sulfide ion. What if I have this ion? Nitrogen, what will its charge be? Everything in this column forms -3 ions. So I know the charge would be -3. And then what would I call that? This is nitrogen. I will keep the first part of the name and put an IDE ending on it. It is not always easy to decide where you cut off the element name. After you see a few of these, though, you will kind of get a feel for it. What if I have this ion? That's arsenic, so that would be an arsenide ion. All right, you should now be able to name all of the simple elemental ions. I am going to throw a name at you and then ask you to write the formula, and the other way around too. So suppose I say, write the formula of the selenide ion. Okay, well, you'll look for selenium on the table, or something that begins with selen. There's selenium right there, and it's in -2 columns. So you would write, the answer to that would be this. Now what if I throw the formula at you and ask for the name? That's what we had been doing over there. I will go and look for something that has that symbol, tellurium. And I'll cut the IUM off the end. Instead of saying tellurium, I'm going to say telluride. You might recognize that name. There's a town out west called Telluride. It's a famous skiing resort, and they have got a lot of minerals that have got this ion in the mineral. So that's how you name elemental ions.